let's look at some examples. So a plane accelerates down a runway at 3.2 meters per second squared. So first thing we're going to do is we're going to write this down. It accelerates down a runway. We're going to have to assume that it starts from rest. Its acceleration is 3.20 meters per second squared. And it does this for 32.8 seconds. And we want to know the distance that it travels. So we need a formula with delta x, vi, a, and t. If we go back to our formulas, what we need delta x, a, and vf. Oh, we're looking for that. We know time. We know vi. And we know a. But what we don't know is vf. We know nothing about that. So the equation that we want is something that is missing vf, but it has all the other four variables in it. And it's the second one. So we want delta x equals vit plus 1/2 at squared. Delta x equals 0 times 32.8 seconds plus 1/2 times 3.20 meters per second squared times 32.8 seconds squared. Let's check our units. This is going to go to 0. We want our units to be in meters. So when we multiply meters per second squared times this time squared, our seconds are going to cancel out. We're going to be left with meters. I'm going to put that in my calculator. I have 0.5 times 3.2 times 32.8 squared. I'm getting 1721. How many significant digits should I have? Well, I have 3 here and I have 3 here. So I'm going to round mine to 3 significant digits. 1721 is 1720 meters. Let's try another one. A race car uniformly accelerates from 18.5 to 46.1. So VI equals 18.5 meters per second, and VF equals 46.1 meters per second, and it does it in 2 seconds, and we wanted to know the acceleration. So we're missing delta x. We want the formula that has no delta x in it. So go back to my equations. That would be my velocity formula. Vf equals Vi plus At. I'm looking for A, so I'm going to go ahead and do the algebra first. I'm going to subtract Vi from both sides. Vf minus Vi equals At. I'm going to divide both sides by t. So A equals Vf minus Vi all over t. Vf is 46.1 meters per second minus 18.5 meters per second divided by 2 seconds. So you see, I am writing down what I know. That's the first thing you do. I'm writing my equation. I'm solving my equation algebraically, and then I'm going to solve my problem. When you do your work, I expect to see all these steps. If I don't see them, then I can't give you any kind of partial credit. I have to know what you're doing and why you're doing it. And I need to see your units. So, it was in 2.47 seconds. Sorry. I'm getting 11.17. This has 3 sig digs, this has 3 sig digs, this has 3 sig digs, so my answer should have 3 sigs. So 11.1 is 11.2. What are my units going to be? Well, I'm taking meters per second and dividing by seconds, so it's going to be meters per second squared. Let's try another one. An engineer is designing a runway for an airport. The planes that will use the airport, the lowest acceleration is 3 meters per second squared. The takeoff speed for this plane will be 65 meters per second. So we can assume that it's going to start from rest. What is the minimum length allowed for this? So we're looking for delta x. What we don't have is time. So we're going to need, an equation with no time. Vf squared equals Vi squared plus 2ax. And we're looking for delta x. So I'm going to get delta x by itself. First, I'm going to subtract off Vi squared from both sides. Then I'm going to divide both sides by 2a. So I listed what I knew. I gave my equation. I solved for what I was looking for algebraically. And now I'm going to solve the problem. So I'm going to put in Vf, which is 65 meters per second squared, minus 0 squared, all over 2 times 3 meters per second squared. The least number of sig digs in my numbers is 1, so my answer just needs to be rounded to 1. On your homework, though, I want everything rounded to 3 sig digs no matter what. But we'll just practice doing our sig digs here. 65 squared divided by the quantity, parentheses, 2 times 3 equals 704. 704 rounds to 700 meters. Notice that one of my meters will go, both my seconds will go. My units on the top will be meters squared all over seconds squared divided by meters per second squared. So my seconds go away and one of my meters are gone. I'm left with meters. And let's try one more. A bullet leaves a rifle. So here's our rifle right here. It's going to start from rest and then it's going to leave at 521 meters per second. And it's going to go through a barrel that's 0.840 meters. So Vi is 0, Vf is 521 meters per second, delta x is 0.840 meters, and I want to know the acceleration. Once again, I have no time. So the only formula I can use is Vf squared equals Vi squared plus 2a delta x. Solving for a, I can use the method that I did yesterday, before. Vf squared minus Vi squared divided by 2a equals delta x. Delta x equals 521 meters per second squared. Notice that I'm putting my units in, minus 0 squared, all over 2 times, delta x and a. I'm finding a this time, times 0.840 meters. So let's do this. 521 squared divided by the quantity 2 times 0.84. I'm getting a very big number, 161572. 161572 to 3 sig digs would be 162123 meters per second squared, or 1.62 e to the 5 meters per second squared.